The application of dispersant fluids from aircraft is an effective way of tackling oil spills that has been used for many years. In 2014, however, European and US aviation authorities declared that dispersants used in aircraft systems were to be classified as flammable. This decision had a massive effect on the industry, and only one aircraft system has complied with the new regulation. It is called Tersus. Tersus is a modular system of dispersant tanks, control panels, and a venting and pumping module mounted on the main deck of the host aircraft. It is powered by normal aircraft electrical supplies and delivers dispersant at pressure to a spray boom mounted under the aircraft. Most importantly, the system has an EASA STC, and since 2016 has been in active service, providing a global oil spill response capability. In meeting the new flammable fluid regulation, Tersus had to comply with aviation standards that had never previously been applied to aerial dispersant systems. For instance, double-skinned tanks, material compliance, fail-safe fault detection systems, fuel venting lightning protection, and 9G crash worthiness. Unlike legacy systems, every component has been designed, manufactured, tested, and certified to aviation standards and released with an EASA Form 1.
Creating an aerial dispersant system capable of carrying flammable fluids in under 2 years was a huge achievement for Leading Edge. One of the major technical challenges was that of material compatibility, ensuring that the many different dispersant fluids carried could be operated and stored in the system. Within Tersus, there are many design and manufacturing innovations that, in conjunction with the flammable fluid requirements, demanded significant certification and regulatory oversight. Operational capability was also a fundamental requirement, especially the ability to operate pressurised and allow the full exploitation of the 727's height, speed and reach. Again, this is unique to Tersus, as other prototype systems can only operate unpressurised, and therefore they cannot travel the large distances in short time frames required by today's and tomorrow's oil explorations. The final test of the Tersus system involved a measurement of droplet sizes at ground level. A further operational requirement defined a droplet size and swathe width, which was taken from many years of industry dispersant practice. Only the combination of spray boom and nozzle assemblies, as approved on the Tersus system, generates the droplet size required to ensure the application of aerial dispersants is truly effective. Put simply, other combinations would be ineffective. The award of the EASA STC in early 2016 was a huge achievement for the programme, and it's fantastic to see the system in service.
After the Macondo incident in the Gulf of Mexico in 2010, the oil industry decided that a jet replacement was needed for the ageing Hercules spray aircraft. An industry-led study concluded that the Boeing 727 would be an ideal platform, and in 2013, 2XL Aviation, a UK-based airline, won the contract to provide this new capability.
The Boeing 727 was chosen for a number of reasons. It's a very stable platform at low level, and the freight hold has a huge capacity for carrying dispersant. From a safety viewpoint, the 3 fuselage-mounted engines mean that in the event of even a double engine failure, the aircraft has excess thrust and suffers little asymmetric effect. Also, with 3 crew, 2 pilots and a flight engineer, there is a capacity to operate the spray system and fly safely in the spray environment, something that the aviation regulators were very keen for us to demonstrate. Boeings have a proven track record of reliability and resilience, and our aircraft have updated avionics and engines, which will see them in good stead for many years yet.
Our Boeing 727s are equipped with a 15,000 litre Tersus system that sprays dispersant through a 10-metre spray boom at the back of the aircraft, below the jet efflux, so we can produce the most effective droplet pattern. The dispersant is loaded by the crew in about 30 minutes and operated by the flight engineer. My job is to control the system and also to monitor the pilots as they fly the aircraft at 150 feet and 150 knots above the sea. Since 2016, we have been on a 4-hour readiness to deploy anywhere in the world.
Tersus can be adapted for any type of aircraft, jet or turboprop, and Leading Edge has draft designs for Boeing 737, 757 and Hercules aircraft. In 21st century aviation, the key is compliance with the highest operational and airworthiness standards, which guarantee that all safety regulations are met. Tersus provides this assurance, is already in service in Europe, and provides the highest possible levels of capability for the lowest technical risk. Tersus is the only aerial dispersant system in the world compliant with the current regulations. It has an EASA STC and has been in active service since April 2016. It is a low-risk, cost-effective replacement for legacy systems that do not meet the new aviation safety standards. Tersus, in service, EASA certified, and with a proven track record taking aviation safety forward.